to Myth-Busting Best Practices in Unreal Engine. I'm your host, Ari Arnbjörnsson. And just a little bit before we start is that I just published the text version of this article just now. So if you'd rather not sit through my antics, you can just leave and scan this. Don't leave, please. No, it was a joke. Or you can search Myth-Busting Best Practices in Unreal Engine online. It should be indexed already, or just go to Ar.games at the top right there. You can share this with your coworkers. So I'll give you one more second. But yeah, best practices. You noticed I put it in quotes, best practices, so-called best practices. The thing about them is that many of them are true. They come from some source of experience, but the thing is many of them are also bust. But in all cases, you need more context. And that's what I'm trying to give you here today with this presentation. I'm trying to give you more context to all of these things. So actually, I want to play a game. And you are all invited to play with me. We're going to play True or Bust. Woo! I will ask you, we have 9 myths. I will ask you which one says this is true. Which one will say this is bust? And I want you all to raise your hand with whichever one you think is true or bust. And I know, many of you are like, it depends. Boring. So boring. I am always going to pick either true with a little asterisk, but remember, or I'm going to pick bust, but I'll always say a but. But I'm not gonna go like it depends, and I don't want you to do that either. So first, I'll give you a myth. I'll explain a little bit about it, and then I'll ask you to pick one. And if I count something that doesn't add up to everyone in here, I will call out the crowd as cowards. You don't want that to happen. But I think you've been good sports so far, so let's see. First myth, don't use tick. Oh, wait. I'll get there. We're going to do this the scientific way. So first, what is tick for the ones who are like, what's tick? Tick is a function that any object can implement, or actor, to have some code running on every frame of the game. And some people online, or even your coworkers, will say, hey, you shouldn't use tick. I want to see how many people here agree with this. How many people here say, yes, don't use tick? About 10 out of 300. How many people here say, this is bust, you can use tick? Hey, come on, okay. I would say about 90% of you, and there's about 7% here that are cowards. Pick one, come on, it's fun. Anyways, let's talk about tick. A lot of gameplay code happens in tick functions. And the ticks, they only run on the game thread, and it's single-threaded. Tick is powerful, all right? We have the tick groups. You can do something before physics. You can do them after physics. Or if you are not, I want to give a special shout out to during physics. If you are not planning on reading any transforms, or if you're not planning on modifying any transforms, instead of doing your code and then the physics simulation, you can do them both at the same time. Quite cool. You also have tick dependencies. You can say, I myself will only tick after that one actor has ticked. And that actor can have another dependency. So that's quite powerful. You can change the tick interval of any actor at any time. For example, instead of ticking every frame, say, tick only like once every 1 millisecond, or once every 0.1 millisecond. You can change that at any time, and you can also disable ticking and enable ticking for an actor at any time. But the thing is, it does have a slight overhead because of those features. And let's talk about this overhead. It is slight, and it is only noticeable when you have lots of ticking actors. But the overhead itself is usually negligible compared to the work you're doing during tick. And I thought, well, I'm wearing a lab coat, story behind this one. And I thought, let's just measure it. Okay, so this is a little this is on my computer, which is a 2.69 gigahertz Threadripper. This is also on Unreal 5.4, so in the future we might make the tick system faster or something, might not apply anymore. And yeah, so this is tick overhead per actor in microseconds. For your information, there are 1,000 microseconds in 1 millisecond. There are about 16 milliseconds per frame in a 60 frame per second game. So if you start having lots of ticks in your game, it will start showing up in 2 places on the profiler. It'll be the queuing of the ticks. And here we have how much time that takes in the blueprint editor queuing of it. We have the Blueprint package development build. We have a C++ editor and C++ package development build. And they're all about the same with a little like fluctuation because of profiling isn't an exact reproducible science. But then we have the tick overhead of actually calling the tick itself. And we have the Blueprint editor, which is taking 3.5 microsecond. We have, when we package it, it already halves. So a packaged Blueprint tick in a development build will only take 1.8 microseconds. And then if you decide, I don't want it in Blueprint, I want to convert it to C++, and you only have a C++ function, it'll take about 0.6 to 0.7, both in editor and a development build. And I know what you're thinking. Yes, I do. Don't correct me. I know what you're thinking. Tick overhead, you see Blueprint editor tick, and you go like, oh, it's so big. It's a big bar. It goes from the bottom to the top of the slide. It's so slow. But the thing is, I think usually having some context makes this, make a little bit more sense. So let's add some context. So here we have, again, the tick overhead from the previous slide, just the overhead, not the queuing. And this is from Lyra. This is from Lyra's player character. And there's a few functions that happens in Lyra's tick function. We have the character movement component. And that takes 241 microseconds, right? Then we have also the player controller itself, which is called in Lyra. And that is taking 125 microseconds. And just those two together, even with the Blueprint editor tick, you know what I measured? I was like, what is the ratio of a Mars bar to its wrapper? And what is the ratio of the tick to those two functions? And the tick is actually lighter than a Mars bar wrapper. And I don't see many people buying a Mars bar and go like, I'm paying mostly for the wrapper. No, and you're not paying mostly for the tick, not in this case. And a little extra case here, you see I had a little extra there. There's the Lyra rifle skeletal mesh. It's taking 20.7 microseconds. And when I saw this on the profiler, I was like, the rifle gun is a skeletal mesh, and I looked into it. It has two animations. One of them is reloading, which the magazine pops out and goes back in. And this one is from when you're shooting. Do you know what the rifle does when you're shooting? The barrel goes like, the tip of the barrel goes like this, a little bit. 20 microseconds, 0.7. And you don't see anyone shouting like, oh, the rifles in Lyra are too slow. No, and you shouldn't be doing that about the tick either in this case. However, of course, it depends. Because if the tick is doing less, let's say the absolute worst thing you could be doing is that you could have an empty tick, because then you have nothing but overhead. And if you have 1,000 actors with an empty tick, well, 3.5 microseconds times 1,000 is now 3.5 milliseconds. Now it's a chunk of your frame time. So how can you avoid an empty tick overhead? First, we have here just don't have a tick function. This is in Blueprint. So if you just don't have a tick function, no tick overhead. Don't worry about it. If you have the ghost tick function, don't worry. Ghosts aren't real. It doesn't tick. But the thing is, as soon as you connect that event tick, it materializes into a real tick function. And if you later decide, never mind, I'm not gonna do that, and you disconnect it, the tick is still there, even though nothing is connected to it. It's still materialized, and this actually is an empty tick function, and it will now take 3.5 microseconds of just pure overhead. People have there's different ways to find this. You can make an asset validator. It shouldn't be that complicated. I actually tried making one, and actually, yeah, I'll add it to the article, the validator, so you can check it in your project. Funny thing is also the Blueprint compiler will decide whether it enables tick or not, and we could just add it as a check in the Blueprint compiler, hey, if the tick isn't connected to anyone, maybe just treat it as it doesn't exist. This is for our engineering team. Let's fix it. I have a comic for you all. Let's say you're doing some blueprints. Maybe you're a junior programmer or a game developer doing some blueprint. You're setting some stuff. The game is running really well, 120 frames per second. Nice. You were like, oh, let's put a sequence here and there. Let's do some incomplete, do a little bit more. Time is going up a little bit. Well, let's get all actors of class. Let's put some more wires in there, right? Connect some more nodes. But eventually, you might start wondering, why is it so slow? What's happening? And someone who's experienced might walk by, you might talk to you online, and they have this they have only time to say this one sentence. They go like, I've seen this before, just don't use tick. And just walk away. And like, a junior developer will have this advice, and like, don't use tick? Like, never? Ever? Is it like a forbidden function? By the way, I got Victor from DevTeam Live to draw these comics for me. If you like these comics, you should go to his website, devteamlive.com. He also has this book, the painfully relatable book about game dev. It's amazing, you should check it out. Thank you, Victor, for joining my presentation. But yes, the issue with tick. People say tick slows down your game, but it's actually doing a bunch of work per frame, per actor that is slow. It doesn't really matter whether you're using tick or timelines or timers, or if you decided to have an animation with an anim notify every frame because I'm not using tick anymore. The overhead isn't usually the issue, it's all the work that you're doing. And if you need something to happen every frame, just use tick. If you need something to happen every frame, and you're like, I'm not going to use tick because I've been told not to use tick, so I'm going to use a timer or a sequence instead, or timelines, I mean, then you're kind of missing the point of why this advice is being given in the first place. It's not the tick is evil function. They're just trying to get you to not do so much work every frame. For Fortnite, for example, we actually have a bunch of ticks. In the Fortnite client, which runs, by the way, on Android and Switch, we have about 80 ticks on average for a single session. So in the beginning, there's of course way more because there's more players alive, and in the end, there's way fewer. But on average, about 80 ticks per frame. And on the server, we have about 700. But try not to do too much work each frame, no matter which method you use, even if you're not using tick. And that can be from either having just fewer ticking actors or doing less work per tick. That should be the advice. And also just don't tick actors that have no business ticking. For example, let's say you have a bullet hell game and you have 1,000 bullets, and these should not each be their own actor with their own tick function, because then again, 3.5 milliseconds of your frame time, which is a good percentage, would just be going to the tick overhead. In that case, you should aggregate ticking. There's actually a great presentation about aggregate ticking by the Sea of Thieves developer online. It was at Unreal Fest, the first Prague one before COVID. So in that case, just make one actor called like bullet manager and have the bullets be, for example, instant static meshes. Then you only have one tick, but you're doing a lot of stuff. And if you do have a lot of data you need to crunch, you can use mass. I'm not recommending this lightly. Mass is like a very involved system. It needs like a programmer, but you have that option. And I was talking to the Unreal Source Discord channel. Discord admins say, woo, they're here. Yeah. So unrealsource.com, go there. There's like 111,000 members there. Anyways, I was talking to them about this presentation, and Chaos Spectrum said, you know what, I think you don't use ticks is bad advice. I think the advice should be use ticks, don't abuse ticks. And I was like, oh, I'm stealing this, but I'm quoting him, so it's not real theft. But when do you know when you're abusing ticks? Well, you profile, just profile, check the profiler. Everyone has access to it. So yeah, when it comes to don't use ticks, I would say this is a bust. You can use ticks. However, don't do too much work in ticks, and of course, don't have an unreasonable amount of ticks running. And when do you know when you have an unreasonable amount of ticks? You profile, okay. Next myth, you cannot make 2D games in Unreal. Who says this is true? You cannot make 2D games in Unreal. I see 1, 2, same amount of dimensions as there are people that say you cannot make 2D games in Unreal. But for prosperity, how many say this is bust? You can definitely make 2D games in Unreal. Okay, no one's going to be called the coward this time. Actually, you know what? I don't know. I've never made a 2D game in Unreal. But it's okay. As a scientist, I asked someone who does. I found someone online who actually is a torchbearer for 2D making games and tutorials. His name is Cobra Code. Cobra Code, can you please answer this myth for me?
Hello everybody at Unreal Fest, and
Where's
thanks for having me as a guest, Ari. I'm Cobra Code, and I've dedicated the last 3 years of my life to teaching people how to make 2D and 2D 3D hybrid games with Unreal Engine. Like most other developers, I also thought making 2D games with Unreal was impossible, or at least unfeasible. Since a few years ago...
Okay, let's do it again.
Hello everybody at Unreal Fest, and thanks for having me as a guest, Ari. I'm Cobra Code, and I've dedicated the last 3 years of my life to teaching people how to make 2D and 2D 3D hybrid games with Unreal Engine. Like most other developers, I also thought making 2D games with Unreal was impossible or at least unfeasible, since a few years ago there really wasn't much information about it available. But after I decided to just give it a try, I quickly realized the untapped potential of Paper 2D. Paper 2D is an official plugin that has been around since Unreal Engine 4.3, allowing us to create sprites, flipbook animations, tile sets, and tile maps inside of the editor, and it's actually active by default in all Unreal Engine projects. These sprite assets can then be used to create 2D games that consist of sprites only or 2D 3D hybrids which mix 2D sprites with 3D elements. However, sadly Paper 2D hasn't been in active development for quite a while, and some features are stuck in a perpetual beta state. Doing things such as triggering events on certain animation frames, multi-directional animations, and switching between animations in general all have to be done manually within Blueprints or C++, which works just fine but can often be cumbersome and time-consuming. This is where the free Paper ZD plugin steps in, which is an Epic Mega Grant recipient and extends Paper 2D's functionality. It allows us to create 2D animation blueprints which look very similar to the ones we get with skeletal meshes, enabling us to use state machines for switching animations, set up animation notifies to trigger events on flipbooks, and it even has built-in support for multi-directional animations with up to 16 directions, making it easy to create top-down games. Using these tools, the possibilities are almost endless, and I've made prototypes for jump and runs, beat-em-ups, top-down adventure games, action platformers, and much more. You may be concerned about performance or the package size, but there are many ways to reduce package size with Unreal. And I've gotten 2D games down to an on-disk size of roughly 150 megabytes and a download size of roughly 90 megabytes. Regarding performance, I was able to make a blueprint-only 2D game run at 370 FPS on the Steam Deck by only changing a few project settings. There are also many more Unreal 2D and 2D 3D hybrid games than you might think. The Octopath Traveler series or Ender Lilies are the most well-known examples, but there are also many other awesome projects such as The Siege and the Sandfox, The Vagrant, Demon Crush, Snacko, Forgive Me Father, and Born of Bread. True or bust? In this case, it's a bust. You can make 2D games in Unreal just fine as long as you know how to work around some limitations and spend a bit of time on optimization.
Thank you, Cobra Code. And actually, since Cobra Code made this video for me, he's actually released the Ultimate 2D Top-Down Unreal Engine course, and I got his permission to give you this link, which has a huge discount on the course. Or just go to tinyurl.com/Unreal2D Top-Down. A few more seconds so you can take a picture of it or something. Okay, thank you for busting this myth. Next myth is blueprints are slower than C++. What even are blueprints? Well, blueprints are Unreal Engine's visual scripting language. It looks like this. It's got nodes, so you don't have to be coding. You can just do some visual magic things. Okay, anyways, people say blueprints are slower than C++. Who says this is true? They are slower. Okay. So about everyone. Who says this is a bust? Blueprints aren't slower than C++. I'm a designer. One designer there. 1, 2, 3, 4, 5, 6, 7. About 7 out of 300. Thank you. Let's talk about blueprints. So blueprints do run in a virtual machine, and there is a set overhead for each blueprint call. But after that, it is all in C++. That means if you have very few calls, you have negligible overhead. And I made a little function here, just an example. And so it prints a string, it does some work for the amount of time that I tell it to do some work, and then it prints a string saying it's done. And calling into a C++ function like that, that's been marked with a U function, you can call into it, it has about 0.8 microseconds of overhead in the editor before it gets into it on my computer on 5.4. And then in a package development game, it takes 0.7 microseconds. But that's not the only overhead. There's also an overhead between the nodes. So in the editor, in Blueprints, it will take about half a microsecond. And then in a package development build, it will take 0.1 microsecond, quite fast. And yeah, how much slower is it? Well, let's check out a few different amounts of work. Let's say do work is doing 1 millisecond of work. This is a screenshot from Unreal Insights. It's the time. It goes from left to right. And then when it goes into a function, it goes down. First, we have print string. Then we have do work, 1 millisecond. Then I have another print string, which in this case is taking 272 microseconds. And Blueprint overhead will show on the profiler as a space between the functions, and when you go into C++ land, it will show as offset, and there's not really anything there. So this function, in this case, is about 0.0000001% slower in that case. But okay, do work 1 millisecond. 1 millisecond is a very heavy function. That's like 4 character movement components. So let's divide it work by 10. Let's make it take about as long as the print string is taking. So here we have print string taking 90 microseconds in this case. I don't know why it jumps between 90 and almost 300, but maybe it's flossing or something like that. Anyways, print string 90, then do work 100, and then print string 95. Now you can actually see, if you squint, 1 pixel between the first print string and do work, and if you squint really hard, you might see 1 pixel, maybe 2 offset between do work and do work C++. But okay, let's say, well, 100 microseconds is still quite slow for a C++ function. Let's go to something a bit more, realistic. So anything between 10 and 100 microseconds. Let's go to 10. Now we can start seeing the overhead. Now we can see the space between the functions, and now we can see the offset. The offset between do work and do work C++, you can see 10.8 versus 10. So that's the 0.8 microsecond overhead that I told you about in the previous slide. But let's say I want to see it with even faster function, a C++ function that does just almost nothing. It's one microsecond of work. In this case, the overhead is actually between the nodes and the offset is a bit more than what the C++ function is doing. And this is when you're calling into C++. There are also other nodes, for example, there's math nodes, set, for each, that are only in Blueprint land, and those are basically 100% overhead because it never goes into C++ land. So why am I showing you all of these different numbers? The thing is, like, how much slower are blueprints? Are blueprints is usually a question, and it's not really a multiplier. Like, it's not like, blueprints are 10 times slower than C++. Although, like, we have set that, but we're always given the context of, like, but it depends. So sure, for some graphs, like if you have lots and lots of nodes doing a healthy mixture of like math and stuff, it might turn out that one specific blueprint was 10 times slower. But usually you should think of it as an overhead per node. That's the overhead. And when it comes to just best practices for blueprints, I actually decided, Michael Alar, I decided to get his input on it because he's been giving advice to Unreal developers online for like so many years, and I was like, Alar, you're so smart. Can you help me collaborate on this? And he's like, I got you, fam. And he sent me this video, which I just put in right now. Let's check it out. Let's check it out together.
Should I use blueprints or C++?
Shut up. Use whatever's comfortable.
But I heard blueprints are slower than
Use the profiler.
Oh, that's it. I thought it would be longer. The other one was like 3 minutes. Okay, thank you, Michael. I actually agree with it. This is quite nice. But I'll add a few more best practices of my own. If the blueprint overhead for some code is causing you issues, you should move that code to C++, because believe it or not, there is no trophy for shipping a game in Blueprint only. I know some of you might be purists, like, I don't want to touch C++. But the thing is, like, if you go to the Game Awards, you don't see Jeff Keighley on stage saying, and for the game, they made a game in only Blueprints. There's nothing like that. There is an award for the best game. You should try to get that, the best game. And if that means moving a couple of your functions to C++ only, even though you don't get to call yourself a purist anymore, if it helps you with the game, you should do it. But that only gets you so far. Let's say you take a function and you see on the profiler, oh, it's so slow. Let's move it over to C++. But oftentimes you're just still doing too much. It's still slow. Like, sure, moving it over gave you like a 20% speed up, but you can't, for the same function, like just do it again. I mean, I guess you could move it over to assembly. Don't do that. Don't do assembly. Sorry, forget I said that. Because oftentimes you're just doing too much. And then you might decide, oh, I know, like all the enemies, they're ticking and they're taking too much frame time. I'll only have the enemies that are close to the player tick every frame. And the enemies that are a little bit further away, I'll tick them every other frame. And the enemies that are behind the player, I'll tick them once a second. And think about, like, those are good optimizations. But the thing is, those optimizations would have been valid whether you're using blueprints or C++. So yeah, like moving things from Blueprint to C++ isn't a Hail Mary. It's not going to make everything like super fast and just run wonderfully every time. Sometimes just doing less per frame by being smart is the way to go. And how do you know whether you're simply doing too much? You profile. You're getting it. Okay, So when it comes to blueprints are slower than C++, it wasn't a trick question, it is true. But that doesn't mean you shouldn't use them. Not at all. They're also super versatile and very fast to iterate on. And they enable non-coders on the team to contribute code, which is very nice. You know what? I did some tests. I ran some numbers. I actually figured out the best mixture, the best ratio of blueprints versus C++ to have in a project. There's a single answer to it. And the answer is, whatever ships your game. That's it. If you are a bunch of designers and you don't know how to code and you want to make a blueprint-only game and ship it and make lots of money to make your next game, that was the correct version, the correct ratio of blueprints versus C++. If you're a bunch of hardcore coders and you hate blueprints with the passion of 1,000 suns, then do it all in code and ship your game and make enough money that you can make your next game. So yeah, that's the perfect ratio. I actually asked one engineer, how much blueprints are there in Fortnite? And they quoted, I don't know if they allowed me to quote them, so this will be an anonymous quote. They said, a lot all in caps. So in Fortnite, we have a lot of blueprints. Next myth, don't use cast. Ooh, spicy. What is cast? Cast is a node that converts a pointer of some data type to another type with type checking. For example, just to give you an example of what it means, like here we have, let's say it's a trap, and we have a begin actor overlap. Whenever something overlaps with a trap, I'm going to say, is this actor, which I don't know anything about, is it the player character? Because if it is the player character, then I can get the reference to the player character. Now I can call functions on the player character. You basically cast to it. But some people say, you shouldn't use it. Don't use the cast function. Who agrees with this? Who says you should not use cast? Let me see the hands. 4, 5, 6 hands out of 300. Okay. Who says this is bust? Oh, you can definitely use cast. Okay. About 80% of you. The rest of you are cowards. Let's talk about cast though. Some say cast is slow. Cast loads assets as a reason to not use cast. But the thing is, the cast function is an integral part of coding in both blueprints and C++. And it's not this slow. It's about half a microsecond in C++, and it's about 3.5 microseconds in Blueprint Editor, which is about the same as the tick overhead, because it's just the blueprint overhead, basically. But this is on my computer, so your mileage may vary. But the issue with cast is that casting to a blueprint type will also reference it, which adds it as a dependency. And dependencies, they need to be loaded before your blueprint is loaded. And they stay loaded while something references them. Give you an example of where this was bad from an actual real-world example. You have a player character, and they have a function called I've been grabbed. And we had this last boss of the game that would do something special when it grabs you. So we would, of course, cast to the last boss and say, if it's the last boss, do something weird. And I'll tell you, like, you can have all the systems in the world for all the enemies, that just always works. But when it comes to your bosses, you're going to need to do some weird stuff all around your game. And like, that's just the way. Like, it's just like bosses are really cool, and they do a lot of cool stuff, and you're just going to have to deal with it. But the thing is, now because of that reference, before the player can be fully loaded, it first also needs to load the end game boss. And while the player is loaded, which is always, the player boss was in memory. So that means that, yeah, the game loaded a little slower because it needed to load the end boss before the player could be loaded. And it also meant that we have memory pressure, like the end boss always, and its meshes and everything in memory all the time. But the thing is, it doesn't slow down the actual cast operation itself. That's always just as fast once you've loaded it. So, okay, when should we then cast the blueprints? I made a flow graph. Who doesn't love a flow graph? And let's say we have an actor reference, and you want to do something with it. What do you want to do with it? Do you want to call a function array, or do you want to get a property from it? If yes, I have another question for you. Is the function or property declared already in C++? Because if it is, let's say in one of the parent classes, because if it is, you can just cast to the C++ parent class, because the C++ classes, they don't count as asses. They're always in memory, and they're quite tiny. So you can cast to them without any penalty of reference loading. So just do that. Feel free. That's fine. You have my permission. But what if the function or property is not declared in C++? I have a new question for you. is the blueprint class expected to be always loaded anyways? Let's say, is it the player character? Is it the game instance? Is it the game mode? One of these classes that you know is going to be in memory at that time. In that case, just cast to that blueprint. Because even though you're adding a dependency, if it's already loaded, Unreal isn't going to load it again. It's smart enough. It'll just go like, I need to load this. Oh, it's already loaded. Never mind. So just cast to the blueprint, cast to the player character, cast to the game instance, go ahead. But what if the blueprint class is not expected to be always loaded? I would say, then get a programmer, or yourself if you're a programmer, to define the property or function in C++, and then you can override it in Blueprint. And that way, you can cast, again, to character. But what if you don't want to call a function on it? What if you don't want to define the property or function in C++? You're going for that purist Game Award trophy, which doesn't exist. Or maybe you're like, there's all these different actors and they have different parent classes. Or I can't or I won't. In that case, use an interface. That's what they're for. Many people will default first to going for interfaces. I would say first cast to the C++, because that's just like, in my opinion, way better. But if that can't or you won't do it, then use an interface. Go ahead. It's totally fine. But now, if you don't want to get a function or a property from the actor, what if you just need to check the type? I would say, don't use the cast function. You should use this function. Compare it with soft class. You use is a of the type soft. So the object goes in and you say, is this a soft class player character? And when you do that, you're not adding a reference because it's soft and not a hard reference. And some of you might be thinking, I've never seen that function before. Well, okay, you got me, it doesn't exist. We added it in 5.5. It's going to exist very soon. But until 5.5, it's fine. You can make this functionality yourself. It's actually quite simple. Just get the player class and resolve it. Casts it to a class if the class is loaded. And then get the actor class and just compare them. And if it's not, and if it isn't loaded, the player class will resolve to no, which in that case, it's not the same thing because it's not loaded. Okay. And also, you can, of course, use actor tags or gameplay tags. Just check, like, does it have a jumper on it? Then probably it has the jump function, something like that. And yeah, but if you don't need to check the type, and you still want to use cast, I don't know what you're doing, but you probably don't need a cast. But yeah, when it comes to don't use cast, I would say this is a bust. You can use cast all you want. Also, if you're doing this in C++, it doesn't really apply there. If you're a C++ programmer, you're already using cast left and right, and you never heard this rumor probably. But yeah, be careful with hard references. That's the only thing. Next myth. If it can be nanite, it should be nanite. Ooh. Actually, I have no idea. I'm not a tech artist. And the guy who said it, Matt Osterley, he got people questioning this one. So I just went to him. I said, Matt, you need to answer this one. You started this. And yeah, Matt Osterley is not, unfortunately, Matt, we miss you, but he is here virtually. So he is going to take over this myth for me. Matt, take it away.
Thanks, Ari. That's right. Some of you may have heard that if it can be nanite and you're using nanite, it should be nanite. But that seems pretty flimsy. The myth I want to bust is everything should be nanite because it will fix everything and run faster always. And I think it's helpful to have a basic understanding of what nanite is doing before we start raising hands. Put quickly, nanite is a virtualized micropolygon rendering system that aims to performantly provide nearly pixel-perfect LODs at a higher level of fidelity than was previously possible than with the traditional lotting and rendering techniques. It does this by first grouping your input meshes into clusters of about 128 triangles, then simplifies that geometry into lower and lower levels of detail. These clusters are streamed in as needed to achieve a resolution of no greater than 1 pixel per edge. Prior to rasterizing, nanite culls primitives, instances, and even individual clusters in order to ensure it only rasterizes what's visible. Then it chooses a rasterization method based on the size of the triangles in a cluster. Bigger triangles use the traditional hardware rasterization path, whereas more dense clusters use nanite's software rasterization path to efficiently rasterize those small triangles. Rasterization sends the pixels occupied by each material to the base pass for shading. So 3 different rocks using the same material all go into a single shading bin. And nanite's new compute shading means it only needs as many shading bins as there are materials visible on the screen at any given time. Pretty great, right? So what do we think? Do we think this myth is true?
You kind of changed the question, but I'll allow it. So everything should be nanite because it will fix everything and run fast always. Who says yes? 1, 2, 3, 4, 5, 6, 7? I like how the hands just keep popping out. 7. Okay, Matt, it's 7.
Or do we think it's bust?
How many think this is a bust? The rest of us. Matt, almost everyone thinks this is a bust. Do you think that's fantastic?
Fantastic. Let's break this up into 2 parts. First, what if I told you not everything can be nanite? Translucency and Niagara aren't supported, and skeletal meshes are experimental just now in 5.5. Additionally, nanite isn't available on all platforms, so if you're targeting those platforms, you'll still need to plan for non-nanite paths. But surely the things that can be nanite will improve performance, right? Actually, it's quite possible to cause new and different performance issues than you're used to from non-nanite rendering. Stacking geometry closely together means that nanite can't effectively cull the clusters of the further mesh, which could result in bottlenecks due to nanite overdraw. Expensive masked and WPO materials can result in significant programmable rasterization costs for nanite and VSM by extension. You can also cause rasterization issues if your WPO material scales a cluster in such a way that its transformed size mismatches its untransformed size, and thus the cluster's raster mode is mismatched. And you can create an excessive number of shading bins using things like dynamic material instances. So what does this mean for our myth? Well, not everything can be nanite, and nanite can cause its own performance problems, which means I think this is a bust. But I don't think that means you shouldn't use nanite. Leaving aside the performance benefits of nanite to the other rendering systems like Lumen and Virtual Shadow Maps, nanite does allow for models with a higher level of detail than previously feasible through its new approach to simplification and rasterization, and it can prove more efficient when rendering scenes through its binned shading approach. Just remember to profile, evaluate, and optimize as you go. Back to you, Adi.
Thank you, Matt. Look at that cheeky bugger. Okay, I actually think he reworded the myth just so that he could say that he came on my presentation to bust himself. Dirty boy. Okay, next myth. Thank you, Matt. Get all actors of class is slow. What is get all actors of class? It's a function that allows you to get a list of all actors of a certain type currently alive in the world. And depending on who you ask, some people will tell you you shouldn't use it because it is slow. How many people say this is true? About a quarter to a third of us think this is true. How many of us think this is bust? You can use that function. A third of us. Cowards. This is a divisive one, but don't worry, I'll get into it. Let's talk about get all actors of class. The thing is, it scales directly with the amount of actors it actually gets. So if you're only getting few actors, a few dozen, it's very fast. And honestly, it's used by the engine. We even call it a few times every frame in shipping builds. There's 3 calls to it by 2 of our subsystems. And some of you might be surprised. And I think maybe some of our rendering engineers or like engine engineers might be like, oh, really? And I might look into it. Anyways, yeah, it's happening. And it's not noticeable because it's very fast, right? It actually uses hash buckets, so it's very efficient. It used to loop over every single actor in the map and check if the actor was of the type. So it used to be slow. It used to be true. But you know what? I decided to check just how long ago was that? It has not done that in over a decade. This myth has persisted. I checked. It's 11 years ago that we changed that. But I will say one thing. We did forget to change the comment for the note. The note says, this is very fast. No, very slow, I mean. Don't use it every frame. Sorry about that. That might have caused a little bit of misunderstanding. My bad. But during this presentation, we noticed it, and we decided to fix it. So in 5.5, this comment has been fixed. Yeah. Woo. So no more misunderstandings. Yeah, thank you, Ben Ziegler, for changing those comments for me. Of course, that just means don't get an unreasonable amount of actors, and don't do too much work for each actor if you're looping through it. Again, just like, don't do too much of anything. However, its siblings, we have get all actors with interface, we have get all actors with tag. They still don't have any hash buckets. They loop over every actor, which is slow if your world gets big. And the bigger your world gets, the slower they get. So that means get all actors of class. It's always fast no matter how big your world is, as long as you're only getting a few actors, like a few dozen maybe up to 100, but after that, like, it does still do a check on every actor. Is it alive? Is it pending like incremental garbage collection? So if you go up in the thousands, you're going to see it. But how do you know how many actors are too many? You profile. You're getting better at that. So okay, get all actors of class is slow. Is that true or bust? I would say this is bust, but for a reasonable amount of actors. And of course, if you're looping through them, make sure that you are mindful of how much work you do for each actor. Next myth. Don't use child actor component. What is the child actor component? So it's a component that allows you to have your actor automatically spawn and attach a child actor during construction. And for some reason, a lot of people say that you just should not use it. How many people agree with that? How many people say you should not use the child actor component? Only like 10, 15% of us? Okay. How many people say this is bust? You can use the child actor component. Go ahead. About 20 to 25% of us. Okay, we're getting more into the weeds now, which I like, but I don't like how many cowards there are in this room. Let's talk about the child actor component. Users coming from other engines will often use it to replicate prefab functionality. When they do that, they encounter issues, instability, and crashes. Because child actor component, it doesn't really stress test our re-instancing system. We do use it. We use it on Fortnite, but for very simple attachments, like only for visuals, for VFX, and we don't do any nesting. Anything more complicated, like if it's related to replication or nesting, you want the child actor within the child actor, or it'll probably give you issues. If you want to get close to a prefab workflow, you can just attach, like within the actor blueprint, the components to each other. So you can have like child components there, not child actor components, just child components. Or you can, even in the world, you can attach pre-existing actors in the world outliner. That's not really a prefab workflow though. Or you can use level instances, which now in 5.5 or 5.4, I can't remember which one, will allow you to do per instance override. So it's like kind of diet prefab. But the thing is, we do have scene graph, which will have a way better prefab workflow. It's the prefab workflow that you know from other engines, not gonna name them, but the ones you kind of expect how it will work, right? And we actually have it right now experimental in UEFN. I don't think you can publish your islands yet with it, but this is a great time for you to finally check out UEFN. Just see how this works for you and if it fulfills all of your conditions, because if it doesn't, you should tell us now, because now we're like, molding it. So if you just forever hold your silence, we will assume you love it. But yeah, don't use child actor component. It's true. Don't use it. I would say that because of all the issues. Maybe if you have very simple use cases, you only want to attach, a visual or like a VFX or something, no nesting, no replication, nothing like that. Sure, do it. That's how we use it. That's how kind of we meant to use it, but we didn't know users would just go like apeshit with it. So don't do anything more with it than that. So yeah, just like as a good rule of thumb, just don't use it. Okay, next myth. Unreal cooks everything by default. Cooks everything. Are, what you cooking? So cooking, when packaging your game, Unreal needs to cook the game's assets to run on the target platform. This is like compressing textures, compiling blueprints, compiling shaders. And you would think that maybe it only cooks only what you use, or you would think that maybe it cooks everything by default. Who here says, yeah, that's true, it cooks everything by default in your project? 1, 2, 3, 4, 5, 6, 7, 8. I see half hands. Put your hand all the way up. Don't be shy. Wow, 9. Okay, 10. Okay, who says this is bust? It only does like what you actually use and stuff like that. Okay, about half of you. The rest of cowards, blah, blah, blah. Okay, let's talk about cooking. Cooking is time consuming. It's very time consuming. If you've seen some of the other talks, we're trying to make it faster. But in any way, you only want to cook the assets your project actually uses. But the thing is, Unreal cannot know which assets you're using or not. Like, for example, what if there's an actor that isn't referenced by anything, but you want to spawn it via code, just with its path? So if you don't tell Unreal which assets you wanted to cook, Unreal will just default to just cook everything. So that's the default. So like, you can break that functionality by just telling Unreal to cook anything, and then we'll just cook that and nothing else. So how do we tell Unreal what we want to cook? There's a few ways of doing it, but I recommend that you use the primary asset rules. And you can configure them in the project setting. Just change the map rule to always cook and disable the editor only checkbox to only cook all the levels in the maps folder and only that folder. And then what they reference and what they reference and what they reference, and so on. And of course, like your game instance, game mode, those will also get cooked, of course, because they're being referenced from the project settings. And I think this should be the default, personally. But of course, I understand. Oh, like what if users want to do something weird, like spawning something dynamically from code? Then okay, let's just cook everything. But if you do that, it's going to be closer to like what I expect Unreal to do by default. And if you need other classes, for example, you have like dynamically spawned enemies or collectibles that you only spawn via code and you want to be able to reference them, I would say make them primary assets. You do that by just overriding the get primary asset ID function and then listing them in the primary asset types to scan in the project settings. That's all you need to make something a primary asset, and you can give it a cook rule. Or you can override the asset manager, which I recommend every bigger studio do. It allows you to just basically go haywire on making like everything super customizable. But for smaller projects, don't bother if you don't need it. There are other methods, of course. You can put something into directors to always cook, or you can use the maps to cook. Yeah, that works. You can use both, either or. I recommend just going full on with the primary asset rules or customizing the asset manager. So when it comes to this, Unreal cooks everything by default. It's actually true, but it's easy to change, which you should do. Okay, we have one more myth, and that is you should avoid redirectors or clean them up as soon as possible. What are redirectors? Glad you asked. They are small meta files that Unreal leaves when you move assets. And this meta file then points to the new location of the asset. And this is needed because Unreal doesn't use global unique identifiers, GUIDs. It uses file paths. So if it's pointing to something and it moves, the asset, it's still pointing there. So the redirector will tell it, oh, look over there instead. Oh. And okay, but people say, the redirectors, don't keep them in your project. You need to avoid making them, or if you do make them, you should clean them up as soon as possible. How many people say this is true? Oh, wow, like 2/3, almost 4, I would say just almost everyone, like 80% of us. How many people say this is bust? 12 out of 300. Let's see, let's talk about redirectors. The thing is, if you're not connected to version control even, Unreal won't even create them in the first place if you can avoid it. It will just fix them up immediately. So if you move an asset, Unreal will go like, wait. And it will go to every asset that points to that asset and say, the asset is over there now, and then resave them. This is a little bit slow, but at least you don't have to worry about redirectors. But they are important in team workflows, however. And I'll give you one example of why you shouldn't fix up redirectors as soon as you can. Let's say Anna creates a new asset, which she has not committed yet, it's just on her computer, and that points to blueprint important. Like this. I practiced this and now I fucked it up. Okay, anyways. If Bill moves blueprint important, Unreal will leave a redirector in case any asset anywhere points to it. The thing is, Anna hasn't committed her asset yet, so Bill might remove that redirector thinking, he fixed up all assets that were referencing it because nothing was committed that does still. Now Anna commits her asset, and it breaks the project because it's referencing an asset which doesn't exist in the location anymore. So yeah, this is the reason. And you might think, this is very rare though. You're right, it's very rare in smaller projects. And as soon as your team starts scaling up, this rare becomes a bit less rare. And it becomes a problem that you have to fix every once in a while. Especially at a scale like Fortnite, this is such a big issue that we actually have a rule of when to fix up redirectors. For us, it's best to do it when you can be sure no asset, whether it's committed or not, is pointing to them. And how can we know that? Well, there's actually one time of year when everyone goes on holiday where we just start a task that resaves all assets and fixes up the redirectors, and then we okay, turn off the lights and leave. Just after everyone leaves on holiday. And you can do that via the resave packages commandlet. We don't really have good documentation about it, sorry. But if you just search for resave packages commandlet, there's a C# file that basically calls the C++ commandlet. There's two classes called resave packages something. Check them out, it'll show you all the parameters and stuff like that. Or maybe if some of you figure it out, maybe you can make an article on ETC, tell me about it, and I'll link it from the text version of this article. Anyways, when it comes to avoiding redirectors, clean them up ASAP, maybe for very, very small teams where you're not worried about it, but I would say this is a bust. You should only clean them up when you know no one else on your team might be referencing them. This was the last myth. We only have 30 seconds left, so I'm not gonna take one question right now. But I will be at the Dev Hub right after this for a whole hour. You just follow me, and we'll go there right after this. But I will just hope you have a great rest of Unreal CL, and I want to say thank you very much.